Welcome back to this channel. Today again we'll be solving a problem related to control system. So let's begin. So here the problem is the asymptotic bode plot magnitude for uh, open loop transfer function of a unity negative feedback system is shown in the figure. If the input is t square by 2 u of t, then the steady state error will be. So here we have been given the bode plot of unity feedback system, the open loop transfer function, and we have to find the steady state error when this input is applied, which is t square by 2. So how to proceed this problem? This is an easy problem. You can try it on your own before seeing the solution. So the solution is as follows. So first what we can do is we can just see what exactly is he asking. So what exactly we are given. So if you see a control system is uh, given like this, okay. So unity feedback means this HS is this part is 1, means we are directly feeding the output to the uh, and we are comparing it with the input. So what we can say here is we have been given this input t square by a 2 u of t, and we need to find the error. So what we have been given is this diagram here, and it shows how the GSHS looks like. Okay, loop transfer function is GSHS, or simply GS here, because HS is 1, because we are feeding the entire output to the input, so HS is 1. So here what we are doing is we are looking we have to guess, or we have to find first GS, okay, so that we are able to calculate uh, the error. Okay, so you can see here that the slope is minus 40 dB per decade, and it is same throughout all the frequency ranges. See, the line is straight and it doesn't bend anywhere, so you can conclude here that the slope does not change, and it is minus 40 dB per decade. So when that can happen is when we have pole at unity, or pole at origin, sorry. So when you have pole at origin and double pole, because one pole is going to contribute to you is minus 20 dB, so two poles will contribute minus 40 dB. So we know now that GS is going to look like k over s squared. So this is confirmed, but still we do not know the value of k. So to find the value of k, we need some data point or some point where the gain is given to us, so that the variable at some frequency variable at some frequency we are given, and once we know the gain, then we will be able to find out what's the value of k. So we are given the gain at omega equals to 0.1 and radians per sec, and that is 20 dB. Okay, so what we can do is we can simply find what is our mod of GS. So mod of GS at is mod of k over s squared. So this is simply, if you substitute k over j omega, okay, squared, this is going to be k over omega squared. Okay, so this is our mod of GS, but we know that the gain will be given in terms of 20 log of mod of GS. So that is equal to 20 log of k over omega squared, and now that has been given to us at omega equals to 0.1 radians per sec, and that is equal to 20. So we have one equation now. Okay, we have an equation now that the gain at omega equal to 0.1 is 20, and from here we can calculate the value of k. Okay, so let's proceed and calculate the value of k. So again I will write the same thing, log of 20 k over omega squared at omega equals to 0.1 is given as 20. Okay, so first we will substitute the value of omega in this equation. So we get 20 log, this is at base 10. Okay, so this is k over 0.1 squared is equal to 20. Okay, so you can cancel these two. Okay, so now what you get is log of k over 0.01. Okay, so this is 0.1 whole squared is 0.01 base 10 is equal to 1. Okay, so now if you take anti-log, then what it will be? If you take anti-log from here, then you get k over 0.01 is equal to 10 power 1. Okay, so which is simply equal to 10. So now from here you know that k is equal to 10 into 0.01 is equal to 0.1. So we have got the value of k now. Okay, so once we get the value of k again, so we now have gs hs or simply gs is equal to 0.1 over s squared. So now we have got the value of GSHS. So now what will be our next step? Next step is will be to evaluate the error. Okay, so error. So again I will show you error how to find. So error due to t square by 2 u of t. Okay, so this is our r of t. Okay, so again let's quickly I will show you the controls diagram. It is y of s, this is r of s, r of s. Okay, and this is r of, this is our error, or in Laplace domain we can write this as e of s. Okay, so if I draw here again in here, so it is r of s, this is y of s, and simply here these two get subtracted and we get e of s. Okay, this part. So what we need to find is e of s. Now we know that e of s is equal to r of s minus y of s. Okay, so once and we know that y of s over r of s is again given by a transfer function 1 plus gs over 1 plus gs. Okay, hs is equal to 1. So if you substitute this here, you will get at the end es is equal to rs over 1 plus gs. Okay, this is what you will get. Okay, so we know that r of t is t square by 2 u of t. So r of s will be Laplace of this. Laplace of this is, we can use 1 by 2 gamma of, see this is 2 plus 1 over s power 2 plus 1. So it is, see gamma of 3 is 2 factorial which is equal to 2. So these two get cancelled and we get 1 over s cubed. So once we have r of s, we have g of s, we can simply substitute it here and we get e of s is equal to r of s, which is 1 over s cube plus 1 over 1 plus, we know that k is already 0.1 over s squared. Okay, this is our gs which we had calculated earlier. So now we have an expression here. Okay, and now we need to find the steady state error. So how we can find steady state error? So let me first write e of s again. It is 1 over s cubed over 1 plus 0.1 over s squared. So how we can find steady state error? It is error at e of t as t tends to infinity. Okay, so this is the definition of error. So now using the final value theorem, what we know that this is equal to, in Laplace domain, this is equal to limit s tends to 0 s of es. Okay, so we can put this here et as t tends to infinity is equal to s of, already we have calculated s cubed over 1 plus 0.1 over s squared. So you can see here that we will get 1 over s squared plus 1 plus 0.1 over s squared. Okay, and this is limit s tends to 0, limit s tends to 0. Okay, so you can again bring down this s square, this you can bring it down, it is s squared plus 0.1 s squared over s squared, so which will be cancelled. Okay, now limit s tends to 0. Now what you can do, from here you can simply calculate the limit. So you can put s equal to 0 in this equation. So once you do that, what you get is 1 over 0 squared plus 0.1. So this is equal to 1 over 0.1. So which is equal to 10. So the steady state error is 10. Okay, so this is how we have to solve a question which is related to steady state error, and a bode plot is given for the transfer function, and which is loop transfer function, and it is a unity feedback system. And first you find the loop transfer function. After that you can simply calculate E of s and use final value theorem and calculate the value of error. So this was for today, and thanks for watching this video, and I'll be back with new question in the next video. Thank you.